The range of a function that is a linear expression will be negative infinity to positive infinity as long as the slope of the line is not equal to 0. So f of x is equal to mx plus b, the standard form of a line. The range will be just b if we have a flat line. It's just this number. But as long as there is some slope to it, whether it's positive or negative, the function will continue to positive infinity in the positive direction and negative infinity in the negative direction. So if you are given just a line, the range will be from negative infinity to positive infinity as long as the slope is not 0. So let's look at the range of a radical. The range of a function that is a radical expression will be determined by the sign in front of the radical term and the constant added outside of the radical term. So let's say this were f of x, and f of x is equal to the square root of x plus a. The range is from 0 to positive infinity. This will continue up and up and up. But if there is no constant on the outside, the radicand can be equal to 0 or greater. So 0 is included. But the radicand cannot be negative since that will result in an imaginary number. It can be 0 or greater. So the range is from 0 to positive infinity. But let's say we decided to add a constant on the outside. If we add a constant c, this c directly affects the y value. You're just adding c. So this shifts up c amount. So now the range goes from c instead to positive infinity, since this is shifted as a result. So when you have a radical with a constant on the outside, whether it's positive or negative, the constant on the outside determines where your range begins. Okay, and that number is included, and then it goes to positive infinity as long as the sign in front of the radical is positive. If the sign in front of the radical is negative, and it goes from 0 to negative infinity, so the range would be from negative infinity up to 0, and 0 is included. Since 0 is the high point, it is the last entry. So that is how the sign in front affects the range. If it's positive, the function is going up. And if it's negative, the function is going down. So keep that in mind when you are evaluating the range of the function of a radical expression. Let's walk through an example together. Let's say you're asked to find the range of f of x, which is equal to the square root of 2x minus 1 minus 4. Step 1, evaluate the sign in front of the radical. It is positive, so that lets us know the function is going to be going upwards towards positive infinity. And then step 2, evaluate the constant outside of the radical, which is negative 4. This is where the range will begin. So the range is from negative 4 to positive infinity. So that is how you would find the range of a function that is a radical expression. Let's now have you try a few practice questions. Question number 1. Find the range of f of x, which is equal to the square root of negative 3x plus 5. Question number 2. Find the range of g of x, which is equal to the negative square root of 5x minus 1 minus 3. And question number 3. Find the range of h of x, which is equal to negative square root of negative 7x plus 7 minus 7. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. F of x is equal to the square root of negative 3x plus 5. So step 1, evaluate the sign in front of the radical. It is positive. So we know the function is going to be trending towards the positive infinity as the high point. And then step 2, evaluate the constant outside of the radical. It is positive 5, so this is where the range will begin. So the range for f of x is from 5 to positive infinity, including 5. So that is the answer to question number 1. Let's now have a look at question number 2. We are given g of x is equal to negative square root of 5x minus 1 minus 3. Step 1, evaluate the sign in front of the radical. It is negative. This lets us know that the function is flipped and it is going to trend down towards negative infinity as the low point. And then step 2, evaluate the constant outside of the radical. It is negative 3, so this is where the high point will be. So the range of g of x is from negative infinity up to negative 3, including negative 3. So that is the answer to question number 2. Let's now have a look at question number 3. H of x is equal to negative square root of negative 7x plus 7 minus 7. Step 1, evaluate the sign in front of the radical. It is negative, so we know the function is flipped and it trends down towards negative infinity as the low point. And then step 2, evaluate the constant outside of the radical, which is negative 7. So this is where the range has its highest point. So the range for h of x is from negative infinity to negative 7, including negative 7.